us for some example problems from 3.8. So very best to knock these out real fast and pay attention to them. So these are three problems that are similar to three other problems you already know, but obviously I would not give you problems. You have homework to defeat the purpose. So here we go. We have number 9, which is similar to good 5 through. You had some pronunciation. Number 9 is x equals cosine times the natural log of t, and y equals the sine times the natural log of t. Parametric equations. We added the parameter. So one way you can approach this is to say, let f of t equal the natural log of t. And then you can say f prime of t then equals the derivative of natural log of t, which would be 1 over t. And then you can look at the movement of the particle following this path. And I think it might be helpful to look at very briefly at the graph of this. If you do f of t equals the natural log of t, then its graph Now think about the slope of the tangent line at any point on this graph. What is its sine? Right, it's positive. And that's important. So we can say that the particle is moving counterclockwise breaking out the cursive, is moving counterclockwise. F prime of t is positive or greater than 0, which is everywhere. And this means that when t is greater than 0, did you notice for this graph here, all t are positive, greater than or equal to greater than. And so this is important. The slope of the tangent line is always positive, and we can say that it's not defined. The motion of the particle is not defined. T is less than or equal to 0. Okay, very nice. There's 9. Then we move on to 13 is a nice problem. I think this will help you with several of your other issues. Hopefully simple. Okay, so here's number 13. A circuit radius 5 centimeters to 1 and trace counterclockwise. So maybe we better have a little review. If the circle is centered at 2, 1 and the radius is 5, any point out here on the circle itself, anywhere in the circle, will have the coordinates x minus 2 squared plus y minus 1 squared equals 5 squared. That's just my favorite there, because the distance here along this first leg distance here is y minus 1. And that's simply saying that somewhere over in here, that's 5, 2, 1, then the origin is somewhere down in here, 0, 0. So if you're looking at the distance along here, it's whatever this distance is minus this little 2 here, and whatever this distance here is minus this 1 here. So that Pythagorean theorem applies beautifully. So quick little review there so we can talk about this. Now, remember from last year, in trigonometry, we said that the x component here is going to be cosine theta, the y component is going to be sine theta, and the coordinates here are going to be cosine theta, sine theta. In this case, if the radius is 5, we would say this x component is 5 cosine theta, and the y component x, the y component, so 5 cosine theta and 5 sine theta, because last year all our unit circles had their radius or hypotenuse of 1. Here we have to multiply each leg times 5. So that is where this whole thing is coming from. And if we want to express this x here, we can say then that it is x equals 5 cosine. In this case, I think our author used t because it's parametric, but it really is the same principle. 5 cosine t plus 2, because we're 2 units above the words, and then y would be 1, 5, 5 sine t plus 1. And that should work. I think that's all they were asking. That one is just to give parametric equations. So that's cool. Feels like there should be more. I think that's all they were asking. So then let's move on to number 24. 8 minutes. Number 24 said find the speed when the particle, find speed, expression for speed when the particle stops. Find expression for speed and time particle stops. Hey Jacob, I heard you were in school today. We're hacking up a lung so you went home. That's a bummer. So I think they gave us this one, the parametric expression, x equals t squared minus 2t, y equals t cubed minus 3t. So, first off, on page 144, we were given an equation which looks suspiciously like the Pythagorean theorem. Again, it's everywhere. We were given this equation, v for velocity equals dx dt squared plus dy dt squared, the square root of the whole thing. That's just a squared. Pretty cool. And if we can get velocity, of course, it's just speed with direction to vector. We know speed out of this, no problem. So keep in mind that because this is Pythagorean theorem, this is just the x component. This is just the y component. So now we can say that, let's do the derivative of those originals up there. The derivative of x with respect to time equals 2t minus 2. And the derivative of y with respect to time equals 3t squared is 3. Now notice, I didn't, last time we had um, those, gosh, I'm drawing a blank right now, implicit derivations where it was the derivative of y with respect to x. Here we're deriving y with respect to time, so we don't have to use chain. Okay, y dt, dx dt, we can keep them separate. So then, we can just plug that in that equation from page 144. Just a little. And we can say that the velocity equals the square root of 2t minus 2 quantity squared plus 3t squared minus 3 quantity also squared. So just plug those in. And we can say that the particle will stop when stops when 2t minus 2 equals 0. Because obviously if 2t minus 2 equals 0, 0 squared is still 0. Or when 3t squared minus 3 equals 0. Same reason. So we could say 2t equals 2, t equals 1, or 3t squared equals 3, t squared equals 1, so t equals 1. So that's definitely the time. And this is 1 second, by the way. And so that's going to be when the particle stops. So life's good. That's about all I can think of. Here's an expression for the speed, velocity, speed with direction. Here's the expression for the speed at any time t. And here is the time t is my second command. Particles, motion particles. That's all they ask for me. So that's pretty good. We're 13 minutes in, so I'll quit, and I hope this is helpful to y'all. If this generates questions, please ask them tomorrow in class. Have a good evening. Happy studying the calculus. Bye.